Okay, so let's wrap up. We're in 1.4, and let's wrap it up by just taking one last look at solving quadratic equations. I will try using all our methods, but however, factoring isn't going to work. All right, factoring only works if our solutions end up being really nice, rational zeros. If they're irrational or complex, factoring is kind of out the door. So since we are talking about having complex roots, complex solutions, factoring is not going to be one of our methods that's going to work. So we have basically the square root property. We've got completing the square, and we have the quadratic formula. So we're going to use those three methods here. So taking a look, if we look at the first one, right, there is no term involving x. What I do have is a term that's being squared. And so if I can isolate that, I basically have the square root property staring me in the face. So I'll begin this one by subtracting 18 from both sides. This gives us 2x squared equals negative 18. If I divide by 2, we get x squared equals negative 9. And so I have a classic square root property now. So if I take the square root of both sides, again, the property means we've also invoked a plus minus. The square root of x squared is x. We have plus or minus. The square root of 9 is 3. The square root of negative 1 is I. And so there's our two solutions. And again, don't forget there are two of them, right? 3i and negative 3i. So we have a purely imaginary solution. In the real world, what this means is I have a system that's purely cyclic, that's in what we call simple harmonic motion. The wave just bounces back and forth, or we just keep moving around in the same circle, the same radius forever and ever and ever. All right, so there's kind of an application for what that actual solution means. So we've done with the square root property. So the next round, right, x squared minus 4x plus 5. Again, looking at my two methods, again, what's nice about these two is they always work, but I'm leaning towards completing the square here for two reasons. One, the leading coefficient is 1 already, so that's already a condition that's met, and then this number right here is even, which means the process of completing the square is going to be pretty easy. So I'll begin by isolating these two pieces. I'll subtract 5 from both sides. We get x squared minus 4x equals negative 5. I'll take my negative 4 and square it, and then I'll take that negative 2, I'll take the negative 4 and divide it by 2, giving me negative 2. I'll square it, giving me 4. So to complete the square, I need to add 4, and to balance myself off, I need to add 4 to the other side. Using this negative 2 here, this side will factor as x minus 2 squared, and then negative 5 plus 4 equals negative 1. Alright, so we're good to go. So we now have, as completing the square sets up, the square root property. So taking the square root of both sides, introducing my plus minus, we end up with x minus 2 since everything kind of cancels out. And the square root of negative 1 by definition is just I. If we add 2 to both sides, we get x equals 2 plus or minus I. Alright, and again, there's two solutions. There's 2 plus I, and there's 2 minus I. And relating this to applications, what we have here is a system that what we say is in resonance. What's happening is we start off with a small wave, and then that wave just keeps magnifying and magnifying and magnifying, which isn't a very good thing. When we have vibrations and they start off with small vibrations and then they keep building on each other's waves, our vibrations start getting higher and higher, and then we start having things break. So that's actually what that system, those solutions for this system, right, would mathematically model something that's in resonance. So there's an application behind the scenes. And then so that basically means the quadratic formula is left. So the first thing that we have to deal with here is the fact that we're not set equal to 0. So I'll just subtract 6x from both sides. We have 11x squared minus 6x plus 1 is equal to 0. And so there's my A, here's my B, and here's my C. So my solution, right, is negative B plus or minus B squared minus a 4 times an A times a C, right, all divided by 2A. Okay, so there's our solution there. We end up with, it looks like positive 6 right? Plus or minus. It looks like we have what here? 36, and that'd be a minus 44 all over a 22. And so x equals 6 plus or minus. I think what we're going to get here is negative 8 all over 22. And if we keep going, this is 6 plus or minus. We have 4i square root of 2 there. Actually, I think that should be a 2, right? Because this is the square root of 4 times 2 times negative 1. So square root of 4 is 2. Square root of 2 is not nice. And then the square root of negative 1 is I. And this is all over 22. If you'll notice, everybody has a common factor of 2. So 2 goes into there 3 times, goes in there once, and goes in there 11 times. So we have x equals 3 plus or minus I square root of 2 all over, it looks like, 11. All right, and again, there's two answers here, right? There's 3/11 plus I square root of 2 over 11, and there's x equals 3 over 11 minus I square root of 2 over 11. And that would be our solution. And again, since we have complex and this is positive, we actually have another case that's in resonance. To get something that isn't in resonance, right, to get a system that actually starts high and then tapers off, that number right there would be negative coupled with that. So again, I'm kind of getting into some engineering applications, but I'm trying really hard to relate math to real life. So we're just solving what seems to be pretty mundane quadratic equations, but when you get into differential equations or partial differential equations and you start mathematically modeling life, these quadratic equations actually have some real life meaning. So again, for the future, but for what we're learning now, right? So I've solved quadratics with complex solutions using all my different methods with the exception of factoring, because nothing factors very well in these cases. But we can use the square root property, we can use completing the square, and we did use the quadratic formula. Make sure you can use all 4 of them. All right, so that wraps up 1.4. Onward and upward to the next module where we'll start doing more equations. I'll see you in the next round of videos.